Hi, and welcome to my presentation of CS50G Introduction to Game Development, specifically the assignment 0, which is relating to Pong. So the objectives for the assignment are to implement an AI controlled paddle to deflect the ball at all times, or at least attempt to deflect the ball at all times. Determine how to keep the paddle moving in relation to the ball. So, whether or not the paddle moves up or down, depending on where the ball is, and decide where and how to implement the code. With these particular three things, one facet to keep in mind is the gameplay. So we need to make sure that it's still a playable game, so that the controller is not too good or not too bad, and that it actually looks like a real player actually playing. I've also added in my own little personal objective for this, and that is to provide the user with the option to play against the computer or play a two-player game, either against a real other person or just playing against themselves, which obviously they're perfectly entitled to do. So how are we going to actually implement this? What are the key parts to actually try and get right while we're doing this? So we need to identify, we need to decide, and we need to recognize. So what we need to identify is the horizontal direction that the ball is moving. So this is the first part. Is the ball moving towards the computer paddle? Now, in Pong, for this one, player 2 is going to be the right hand ball. So is the ball moving in a right direction? Is it moving towards it? That is the, I need to start thinking about possibly moving my paddle now. Decide when the computer ball will actually start to move based on the ball's position on the horizontal plane. So whereabouts in the actual playing surface does it actually then start to go and try and find the vertical position, where if it's going to be as soon as it hits the other paddle, then the probability is that it's nearly always going to actually hit the ball, and from a gameplay perspective that's not going to be very good because the user's really never going to win. However, if it doesn't start moving until the ball is literally on top of it, then it's going to be way too easy, and it's not a pleasant game. So we need to find a medium between exactly when it starts moving. I didn't want to adjust the paddle speed. I wanted to maintain that as the same for both players. So this is the way to determine the hardness of the game, or how easy or how difficult the game is. And then we need to recognize how the computer is actually going to know in which direction to move the paddle, or in fact not to move at all. As okay, yes, it needs to move towards the ball, but if the ball is within the paddle boundaries, you also don't want it to move out of the way. And we also need to make sure that when we do this, that it doesn't impact the sort of the graphical representation of the paddle. So if there was an overlap between the two, you'd see it jiggling around, that sort of thing. So how were these achieved? What did we actually do in the code itself to actually achieve these things? Well, let's actually have a look at the code, shall we? So let's here we dive in here with our code, and I will just pick it up myself. So what we need to do first is the horizontal direction. So actually determine whether or not the ball is moving left or right. So this actually takes place within the love update component of the love update function, and it occurs after we've determined whether or not the player has scored or whether or not it's hit a wall. So after all of those, then we determine whether or not it's right or left, and here it is. Here's the bit of code. So if the ball's horizontal direction is greater than 0, then it's a positive, then it's heading right. If it's negative, it's heading from right to left, then it's left. And if it's not doing either of those, then it's still. So that's how we determine whether or not whether or not it's heading left or right, and that's actually stored within an attribute, a new attribute that I've added onto it within the actual ball class, which is just here, and it's defaulted to 0. So when the ball is reset after a win, or when the game's about to serve and start, then it will default it back to not moving at all. So the next bit that we needed to do was decide when the paddle was going to start to move. Now, in this case, it seems a relatively arbitrary figure of 288. Now, what that actually is, that boundary point, is the boundary between the second and third part of the screen in the direction of going towards the computer paddle, player 2, on the right. So you have 1/3, then you have the centre third, then that boundary point between the second third and the third third is when it starts moving. Now, that figure I came up with basically through gameplay with myself and also with my children, and we found that that was a good place, in terms of hardness of our own ability to play the game. Now, the interesting point about that is that you could actually change this figure to increase or decrease the hardness of the game, and you could actually turn this into a variable with set presets, and that you could allow the user to actually determine how hard they want it to be. So that would be, potentially for future development. And then the next part is in which direction should the actual paddle be moving. So it's determined that the ball is heading in its direction. It's now within the, just coming into the third of the screen, so it now needs to start taking action. Well, how it does that is to look at the its own vertical position against the ball's vertical position. Now, I did actually put this right into the center of the paddle, so these figures here, the 10 and the 5 and the 15 were actually both 10, which is right at the center. Now, I found when the paddle was produced on the screen, it was actually vibrating as a result. So what I actually did is I created two boundaries. I created an upper boundary, which was 5 points down from the top of the paddle, and the bottom boundary, which was 5 points up, or 15 down from the top of the paddle, because the paddle is 20 in length. So when the the top boundary is greater than, so when the top boundary of the player's paddle is greater than the ball's position, so it's lower down the screen. It needs to move up, and that's what the negative paddle speed means. It means to move up the screen. So the as you know, it would be 0 at the top, and then down at the bottom, which would be about 200 or so odd. So this means the actual the paddle boundary is below, this top boundary is below the ball. So you want it to go up, so minus, so you want to decrease the pixel position. And obviously, the opposite is true. So the lower boundary, when that is less than the ball's vertical position, then you want to move down. And then if it's actually in the right position, then you don't do anything at all, which is great, and that's fantastic. Now, before we nip into the demonstration, the final bit that I wanted to do was just talk about my own personal little attributes very, very quickly that I wanted to add into this, which was the being able to select against one player or two player. So the way to do that is we'll have a look at the first part, which is actually selecting whether it's a one or two player and telling the person what to do. And we can see here. So I've created a new game state called type, and it occurs immediately after start. After you press enter to say yes, I want to play a game, and you select a game type. So you press 1 to play computer, or 2 for player 2. Quite straightforward. So that is then picked up within the key press component, and here we are here. And so if 1, then we set, and the game state is set to type. then what we do is I'll create a new attribute for the paddle, which is then put into player, called isComputer, which is a boolean, and that is then set to true if it's a 1 player because they're pressing 1, or if it's 2 player it's set to false. And if we had a look at the paddle, we can see this new attribute which is defaulted to false, so it's defaulted to 2 player game. And then finally, once we game, so we need to prevent the a player sort of intruding on the computer game. So it's the first selection is if the player is true, then use the logic for the computer generation. Otherwise, it's the keyboard, the standard keyboard thing. So that's the actual code that's been implemented. So let's have a look and hopefully see it working, which would be fantastic. So we'll just have a go on this now. So you can see I'm able to move, and at the moment the player 2 is able to move. So we press enter. We can now see that the select the game type, press 1 for against the computer, or 2 for player 2. So let's press 1. We're now going to serve. So let's see if it works. And as you can see, I'm moving now, and that's paddle 2 computer. Now it's me. Let's see if I've scored. I think I've got a point here. Oh, check me out. Bloody good, aren't I? Okay, me. Let's see if he can beat me. Oh, I've got another. Oh, look at that. There you go. Lost. Well, that's my adaptations. That's my changes, and that's the end of the assignment. So thank you very much for your time and listening, and see you later.